So I have a different video about the lab, and I'm going to just use this as my backdrop where we'll do a bunch of review. This is the review for the test part on this video. All right, so let's get ready for that test. Here's something that we haven't talked about in a long time. F of negative x is equal to f of x. Who can tell me what rule that is? Pausing. Okay, so this one was the even rule. And let me give you an example of how you could use it to prove something's even. Let's start with this one. F of x is equal to 2x squared. We would never give you one this easy, but I want to start with an easy one at least. The first thing you do, somebody tell me. Come on, you guys are the worst class at participating. I only have 2 kids that usually raise their hand. Just, I do move it around and ask people randomly. If you like that, then keep not raising your hand, because I gotta randomly call on somebody. Okay, fine. I'll use dice, that way it'll hit people completely random. Row 3, person 1. That's you.
You said 2x squared is negative, so f of negative x?
F of negative x, yes. We put in a negative x. So 2 parentheses negative x squared. Row 4, person 4. 1, 2, 3. That's you. What do I do after I stick in a negative x? You simplify it. Can you tell me what it simplifies to?
F of negative x simplifies to negative x.
We're just simplifying this, that's all.
Oh, it goes to x squared.
Yeah, so what do I write?
You write 2x squared.
2x squared, good. Now, if you can write this, f of negative x is really equal to f of x, remember this? Then you're saying that it's even. Is this really f of x?
Yes.
Yeah, it is, because look, it says it's f of x. And so, it's really f of x. And 3 dots in a triangle. Do you guys know that that means therefore? It's a lot faster than writing therefore, and it's a lot cleaner too. Therefore, it's even. That was a proof. We did those about a week ago. Raise your hand if you feel like you could do that again. All right, since that's only half of you, we should definitely try it again. You ready? Everybody prove that this is either even or it's not. Everybody prove if this thing is even or not even. Pause for a second while you give it a try. All right. So here's your steps. First step, put in negative x. Second step, simplify it down. Third step, realize whether or not you've got the exact same f of x back again. Is this really true right here? Is that f of x? Then you just therefore proved it's even. Now raise your hand if you think you can do this. Okay, I'm up to almost everybody. Okay, next one. I want you to prove this is odd. It's more complicated. 4x to the 7th minus 3x, just x. If that's f of x, prove it's odd. Now some of you might be thinking, well, I'll just prove it's not even. That doesn't prove that it's odd. The odd proof starts with sticking negative x in like the other, but it ends differently. I hope you remember. For negative x to the 7th minus 3 negative x. Then you simplified it, and what'd you get?
Negative 4x to the 7th plus 3x
All right. Now, do you know what you were supposed to prove?
F of negative x equals negative f of x.
Now, we have a negative out in the front. But is this exactly the opposite of the original? Here's what you needed to do. You needed to factor out a -1. Who remembered to factor out a -1? Ooh, only a few of you would have got the point then. Because you'd have to factor out the -1 and show that when you factor out the -1, that you now have f of negative x is equal to the negative and then the f of x. See how here's the negative, just like we wanted, and here's f of x, just like we wanted. That's proof. Yes?
I wrote like the negative f of x equal to -1 and then 4x to the 7th minus 3x, and then I just distributed it, and then I wrote that f of negative x equal to negative f of x.
Depending on how you showed that exactly, I might have given you credit, but do you get having it factored like this is a very elegant way to do it? That's what I'd do on the test, because I'm not promising to give you credit for some other way. It depends. Depends if I could look through your work and see that you factored out a -1 in a different way, that's okay. All right. So that's proving things are odd or even. We've had a lot of stuff that we've covered, and I can't cover it all today, which is kind of handy that we have an extra review day on Monday. Okay? But I think we can cover a couple more things, and then your homework is going to be, there are some practice problems that are called notes. I didn't want to do those for you. I wanted to leave those for you as some practice problems that you can do. There's a second thing called a quiz. That is for sure assigned. You need to do that over the weekend. The other ones, if you want to save some of those for being done later, that's fine. But for sure, the homework, do the quiz in there. And there's an answer key for the quiz, so do the quiz. All right, but here's one of the things that's on the quiz, and let's see if you remember this. Let's say I took a function, and it started as x minus 3 squared, and then I added 1. Would you know what that would look like? I'd sketch it if I were you, because it'll make it a lot easier to answer these questions. When is it increasing? When is it decreasing? What's its local min? What's its absolute max? Braden, can you describe what shape this thing is?
Parabola.
And which ways was the parabola been shifted?
Right.
And?
Okay.
All right. So if I go to the right 3 and up 1, I'm going to put a dot right there. Then my parabola goes something like that. Do you generally approve? Other than my drawing is kind of messy. Braden?
Yeah.
Okay, good. Then, what's the local min, Braden?
3, 1.
Yep. It's that spot. Okay. And where is it increasing, Michael?
Increasing, it is increasing anywhere that is,
You have to say it in an interval.
okay, wait, it's increasing negative parenthesis, negative infinity.
Nope. Increasing. It starts
Oh, this is
increasing.
X value,
Yep.
okay,
It starts increasing at,
3,
there you go, comma, and then increases to, well, how far does it keep increasing? All the way to infinity. Good. There we go. Has to be in that order. Yes. Question.
I I thought it was like increasing like the Y value against.
Yeah, the question isn't how high does it increase to? That's different. The increasing interval is from here over, it is increasing. So from 3 to infinity. All right. And the decreasing interval. Hannah, you got this one?
Decreasing interval would be from infinity to.
Close, except it starts from way over there, and that's not regular infinity.
Negative infinity to 3.
Negative infinity to 3. And we could argue about whether that's a bracket or parenthesis, but when you're doing intervals for increasing and decreasing, just use parentheses. Okay. What if I ask the range of it? Jake, do you know the range? I know I didn't ask it before, but I'm asking now.
Isn't it 1 to infinity?
And does this matter if I use parentheses or brackets? Yes. So, should that 1 be in parentheses or a bracket?
Bracket.
Yep. Okay. Absolute max. Some kid's going to write infinity, and I'm going to mark it wrong. What's the right answer, Joe? I would agree with that. Or there is no absolute max. All right. Next, what we have to do is I give you a little function that looks like that. You should be able to make the reciprocal. Now, I'm going to label this because it kind of matters. I'm going to say this is at -3 comma -1. I'm going to say this spot here is at 7 comma -4. I'm going to say that spot right there is at 1 comma 3. Try to make the reciprocal graph. Remember, it has asymptotes. It has a few key spots at 1. If you know what I'm talking about, that'll help a lot. I'll pause for a second. Okay. If you understand this and feel pretty confident, I promise not to even call on you. Just raise your hand if you feel like, I think I get this. Okay, that's most of you. Good. Well, now I'll see you again in a minute if you still feel that way. Asymptote runs right through there. Because why? Because you can't take 1 over the y value at that spot. The whole point of this is you're doing 1 over the function. And f of x is also y. You can replace f of x with y, and you want 1 over the y values. And there's no way to do that at the x-intercepts, also known as the zeros or the roots. Okay, the next important spots are at 1. And that you kind of have to do a judgment call on where 1 would be. Except that one for sure is 1 right there. I'm going to say that's at about 1 and that's at about 1. And also there's one that's going to hit -1 at about there. Okay. And then here's where I would say most kids would get this part right. And if I were to predict a lot of people making mistakes, it would be on the endpoints. On this one, sometimes kids just can't see it. But it goes this way because it has to get closer and closer to the asymptote. Okay, and then this last one, it has to get closer and closer to the asymptote, so people often will do this, but then they don't know what to do right here. So what I'd do is just take that 1 point, and I would make, okay, what's the new point got to be? Well, it'd have to be 1 over -4, so 7 comma -1/4. And that would be about here. And then I can go, okay, there's a logical connection there. Now, was I perfect? No, I didn't. I should have gone straight exactly above this. But so I was off a little bit on exactly where it was, but that's pretty close. Now, how many of you feel like, yeah, I think I get this? All right, good. Then there's one last kind. I'm going to use, I like my baseball cap example, except I'm going to have it backwards this time. So if that's my function, would everybody please take and do the 2 different kinds of f of x, which one where you go there on the absolute value or on the outside of it, do that first. And then if you have a way to copy and paste, use the same parent function and then do the absolute value on the insides. Okay, here's how this one goes. First, the things that were y's that were negative, they end up bopping back up here because they can't be there because the y's that were negative have to go away. And includes the black part and the red part. Raise your hand if you had that one right. Okay, good. And then I'll take the same exact graph with the backwards baseball cap and say this part has to go away because if your absolute value around just the x's that were negative have to go away. And this black part comes in, which is creating or making y be a line of symmetry right down the middle of it. So it's the black part plus the red part. All right. Start reviewing. If you wait and do all your review on Tuesday, you'll probably suffer on Tuesday's test. Tuesday's the test. You could review Monday night also, but review this weekend. That's all I got for you for the video for today.